Hello again. Today we're going to talk about multiplying polynomials, and I'm going to show you 4 different ways of doing it. The first 2 will be the keys, the main ones that people enjoy. The last 2 will be just for explorations purposes. The first method we're going to talk about today, distribution. Now, I've got 3 steps here on the side. Step 1, step 2, step 3. We're going to be multiplying polynomials. I'm just going to review. Polynomial is many terms. So this one right here, this is a monomial because there's one term, 7n squared, times a binomial, n plus 2. So I'm going to write mono times bi. Monomial times a binomial. Well, if I'm going to do the distribution method, now I'm going to start with step 1 here. Write the 2 polynomials next to each other. Make sure you are multiplying and not adding. All right, so I'm going to write 7n squared times n plus 2. Multiply every term in the first parentheses by every term in the second parentheses. If we're going to use FOIL, that's when you have 2 binomials. A binomial times a binomial, like down here. See where I'm pointing now. And then we're going to combine like terms. All right. Well, the way I like to visualize the distribution method is this. Imagine that this person is coming to visit the house where these 2 people live, because it's a binomial. There's n and 2. Well, when they come in, they're going to shake hands with n and shake hands with 2. That's how I visualize this. So I'm going to say 7n squared times n. Well, I'm going to write it out for us. 7n squared times n. This plus sign goes here in front of the plus 2, plus 7n squared times 2. This is how the math works. I'm not going to do this every time. I will just do it for this one. So 7n squared times n. Well, I've got 2 n's in the n squared. I got 1 more in the n. So I'm going to have 7n cubed plus 7 times 2. They make 14. And the n squared is still there. It did not have another n to multiply with. So it's kind of, it's just there. This will be our answer. So I'm going to see if I can do that just by distributing. 7n squared times n. I'm going to draw that arrow. This person comes to the house, meets up with n, shakes hands, and they get 7 times n. There's now 3 n's. Then the 7 times 2 makes 14. It's positive. The n squared had no partner, so it just stays n squared. So I'm not going to do this part anymore. I'm just going to go straight to here. So let's try another one. I got a whole bunch here on the left side. I'll do this one. Do you see that 2 right there? This is negative 5n minus 6 squared. That squared tells me I need to write this twice. So I'm going to write it twice. Negative 5n minus 6 times negative 5n minus 6. So that's what the square here tells me to do. All right. I now have this binomial, these 2 people meeting these 2 people. So remember where I said up here at the top, FOIL is for binomials. I'm circling it right now. FOIL stands for 4 words. First, outer, inner, and last. What that means is this. First, these 2 people are going to shake hands, the first person and the first person. So negative 5 times negative 5 is positive 25. N times the n makes it n squared. Okay, that's the first. Outer. Well, the outer 2 are going to shake hands. So negative 5 times negative 6 is going to be positive 30. There's an n on the 5, but not with the 6. Inner. Well, that means these two inner ones are going to shake hands. Inner means closest together here. So this negative 6 times negative 5n. Negative 6 times negative 5 is positive 30 with an n. Okay. And last, we're going to do the last one now. The 6 is the last one in the first parentheses, and the negative 6 is the last one in the second parentheses. Negative 6 times negative 6 is positive 36. Okay, write the two polynomials. I'm going over these notes up here. Make sure I'm multiplying. I did multiply everything. Multiply every term in the first parentheses by every term in the second parentheses. So if these two couples meet, did everyone get a handshake or a elbow bump or a hug, whatever it is? Yes, everyone did. Now, these two people, they already know each other. They don't have to hug each other. They don't have to say hello. These two, they're in the same family. They don't have to hug each other or say hello. Okay? Combine like terms. We're on this step right here. I'm going to circle it. You see where I'm at? Now step number 3. Combine my like terms. 25n squared, 30n, 30. These are like terms. They both have the same n to the same first power. So 25n squared plus 30 and 30. Now we're adding 60n plus 36. That's my final answer. I have a trinomial, 3 terms, an n squared, an n, and an n to the 0 power. All right. Let's see. I'm going to have to erase some of this so that we can try one more. I'm just going to show it to you. Three n squared minus 3n minus 3 times n plus 3. Now, having a trinomial, and I'm going to erase this after I show it to you. I'm going to go like this, like this, like this, like this. Now this negative 3, it's like I got to go like that. It gets too confusing. Okay, it's just too many arrows, so we can do it this way instead. Watch carefully. You ready? I can go like that. So this n in the second one, because it's a binomial, it's easier to draw the arrows backwards. There will be less confusion, and it'll be easier to see. So this n times, I'll go with the highest power, times 3n squared is 3n to the third power. This n times the middle one, negative 3n squared. This n times the last one, negative 3n. Okay, I'm going to change colors, and now I'm going to go the 3 here times, well, kind of hard to get there, but it's there. 3 times 3n squared, positive 9n squared. To the middle one, 3 times negative 3 is negative 9n. 3 times negative 3, negative 9. So I did multiplication. Every term in the first parentheses and every term in the second parentheses met and multiplied. We can say shake hands, but I now have 1, 2, 3, 4, 5, 6 terms. I need to combine my like terms. That's my last step. So 3n cubed, there's no other 3n cubed, so I just write 3n cubed. The negative 3n squared and the positive 9n squared are going to combine because they both have n squares. Negative 3 plus 9 is plus 6n squared. The negative 3n and negative 9n, they will combine. Negative 3 and take away 9 more, negative 12n. And then this negative 9 is all by itself. So I now have a 1, 2, 3, 4 term polynomial. That's going to be my answer. The distributed method gets kind of confusing when it becomes big polynomials, trinomial and a trinomial, or even beyond. So in Algebra 2, this becomes cumbersome. I'm going to show you a different technique. Next page. This is a very popular method. It's good. It's a good visual. You can see things very easily. And if you know your science class, your biology, you can think of Punnett squares. So Punnett squares. I want to show you how this works. So step one. Step one says to determine how big to make your box, you must know how many terms are multiplying by how many terms. Well, the easiest one here, I've got a monomial times a binomial. Mono and a bi. So that means I'm going to make my box 1 tall and 2 wide. I'll put the 2k here, 7k, and the 4. The 4 is positive, so I don't have to put the plus sign. I just leave it as a positive 4. In this first box, I'm going to put the result of multiplying the number above and the number left. So 7 times 2 is 14. K times k is k squared. Fill in the box with what you see above and to the left, they multiply. The next box, I'm going to multiply 2k and 4. 2 times 4 is 8, k. This one is done. $14k squared plus 8k. Now, you're thinking, wouldn't it just be easier to go like this? Do the distributive, it's a lot more simple. I think so too, but I'm showing you this method and how it works. I did it without actually reading the directions. So I'm going to do the next one with the directions. I'm going to choose the one at the very bottom of our screen. Let's see what I got right here. Move this one down. And I'm going to change colors. To determine how big to make your box, you must, okay, I've got a binomial and a binomial. So that means I'm going to go a box that's too high and too wide. Well, I'm going to make this box even bigger because last one I had to squeeze it in. (8v negative 2), 8v minus 3. Put the terms of one polynomial on top, that's the 8b minus 3, so this one went up on top, and the other polynomial put on the left side. Each box is the product of the term above and to the left of the small box. So let's see what this looks like. This box right here, I've got 8 times 8, that's 64, v times v, v squared. This box here, 8 times negative 2 is negative 16, v. This box, negative 3 times negative 8, negative 24, v. And then this box, last one, is negative 3 times negative 2 is positive 6. I do not put the plus sign. I only put a sign when it's negative. If there's no sign, it's automatically positive. Well, the nice thing about using Punnett squares is when you do it like this, the numbers on the diagonal are oftentimes like terms. So here, step 4, I'm circling it, combine like terms, usually on the diagonal of the boxes. So I'm going to write my answer. 64 v squared. Negative 24 plus negative 16, that's more negative, so negative 40. And then this box, positive 6. A binomial times a binomial gave me a trinomial. And that's very common. Doesn't have to be, but it's very common. That's how the box method works. I'm going to show you another one where it's a lot longer and where the box method becomes kind of more fun and more reliable. So I'm going to make sure you have these notes. I'm scooting down the page. Let's try this one. I'm going to make it 3 boxes tall, 3 boxes wide, because I have a trinomial and a trinomial. I got 1, 2, 3 times 1, 2, 3. I could use a distributed method and go like this. 1, 2, 3. Change colors, go 1, 2, 3, and change 1, 2, 3. I could do that. I'm not going to, because it just gets too confusing. I'm just going to do the box method. Change my color. So I'm going to put this one on top. 6x squared plus 5x. I don't need the plus. I forgot that. This one goes on the side. 3x squared. 2x. All right. So this, let me just check my steps really quick. To determine how, yeah, I made it the right size. I put one on top, one on the left side. Each box is product of the term above and to the left. Okay, I'm about to do that. And then I'll combine like terms. Okay, so we're on it. Totally on it. I'm going to do the top. I always start top. This is always my first box. This is always my last box. However you do it is okay. 3 times 6 is 18. X squared times x squared is actually x to the 4th power. I'm going to go right. 5 times 3 is 15. X squared times x is x cubed. Going right again. 5 times 3 is 15 again. X squared is only x squared. Okay. Going down one row, I'm going to do the row of 2x times 6. 12. X squared and x makes x cubed. 5 times 2 is 10. X and x, x squared. 5 and 2 is 10 with an x. Down to the row of 3. 3 times 6, 18 with an x. 3 times 5 is 15. Oh, wait. This had an x squared on it. Yeah, I almost forgot that. Here in this one. And the reason I knew is because this one had an x. And these two should not have the same x to the same power. I knew this was an x, so this one, and I knew this one was an x, so this one here had to be x squared. I caught myself. Then the last one, 5 times 3 is 15. Okay, we talked about how there's diagonals are usually like terms. Let's look. X cubes, yes. X squares are all x squares. X to the 1st powers, yes. Those are my diagonals. I can write my answer. The first one, 18x4. The second, going from highest power to lowest power, like we've been studying, 12x cubed plus 15x cubed is 27x cubed, and that's a plus sign. The next set of diagonals, the x squares, I got 18x squared, 10x squared, and 15x squared. Well, that's 28, 38, 43 x squared. Now I'm going to this diagonal. 15x and 10x is 25x. And then plus 15. So a trinomial times a trinomial gave me a 1, 2, 3, 4, 5 term polynomial. So the box method can get as big as you want. That's one of the powers of it. I'm going to take just a little bit of time to show you 2 other methods briefly. And I'll tell you what they're useful for. So this method is called the vertical method. You prepare to multiply just like you did in 3rd grade by putting the two polynomials on top of each other, usually putting the longer one on top. So if you remember from having to do this long time ago when you had something like 24 times 185, you would go like this. Put 185 on top and put 24 on bottom. You put the times sign, you go like that. It would multiply. 4 and 5, You put your numbers here, then you put a 0 here and put your numbers there, and you add straight down, right? This is the exact same technique. This is very useful in, it's good all the way up until calculus. It's good in pre-calc. So if you're not going into calculus or pre-calc, just do one of these. You can use the other two methods, method 1 and 2. If you're planning on going to calc or pre-calc or beyond, check this method out, give it a shot, and use it when you feel it's most useful. It's like having more tools in your tool belt when you are a person working, either a doctor or a construction worker. The more tools you have, the more you can do. Okay, so what I'm going to do is I'm going to try one of these out. First, I'm going to erase this original note so I can have some space to write. And I'm going to pick one of these. I will try, which one? Let's do this one. So this is the trinomial. I will put it on top. The binomial I will put on bottom. 3r squared plus 7r minus 7. 5r plus 5. I want to multiply. I'm not going to put the little x down there, but I will go 5 times negative 7 is negative 35. There is no carrying like you did back in 3rd grade. Every number goes in its own space. Okay, now I'll go 5 times that positive 7r. I'm going to get 35r. It's positive. 5 times 3, the 15r squared. Okay, put a 0, whatever you want, there. Now I'm multiplying this and this. I'll change colors, make it easier. Multiplying everything here, this 5r times all 3 terms. 5 times negative 7. 5r times negative 7 is negative 35r. 5r times positive 7r is 35r squared. 5r times 3r squared is 50, that's plus 15r cubed. Okay, add straight down. I got a negative 35. 35r, take away 35r, they cancel each other out. 15r squared plus 35r squared, that's 50r squared plus sign, and 15r cubed. This little gap here just shows that I'm missing one of the terms, which is fine. I have a trinomial. My answer will be 15r cubed plus 50r squared minus 35. This can work with any polynomials. It's a powerful technique. You may not want to use it if you're going to stop at Algebra 1, Algebra 2, Geometry, or IM1, IM2. If you're not going any further, this is good. I will show you one last method. This last method is called the area method. And this is a method that helps you visualize how multiplication of polynomials works. In Common Core, they use this starting in 3rd grade, and this area method works all the way into calculus for, I believe, integrals and derivatives. So it's a powerful method. It's a great way of seeing how it works and connecting it. For those of you who are visual learners, this may be something to look at and try. So first one I'm going to look at is on top. This one. This is what a 2nd grader would do. When they're doing 13 times 16, they'll do 10 and 3 times 10 and 6. The 10 and 10 make 100. The 3 and 10 make 30. The 6 and 10 make 60. And the 6 and 3 make 18. Well, it's just like multiplying vertically, but you now have a visual model. There are 100 squares in this red square. There are 60 squares in this green one. There are 30 squares in this green one. And there's 18 squares in this blue one. If you add up all the squares, you're going to get the same number as doing the box method or doing 13 times 16 and multiplying like that, you're going to get the same number. 100. 30 plus 60 is 90. Another 108. 208. Well, in this technique, this right here, I'm looking at this one. I've got 2x minus 1 times x minus 1. This down here is minus 1. So this is 2x minus 1 times x minus 1. And x times an x will give you a positive x squared. This positive x times that x again will give you another positive x squared. I now have 2x squared. This negative 1 times my x is negative 1x. And down here I have a negative 1x and another negative 1. So I have negative 3x. And I've got a positive 1. You get the same answer as if you did distributive method or the box method or the vertical method. But here now it's a visual that you can see. And I just want to show you what it looks like when it's, this is another one from 3rd grade or 4th grade. And down here is what you're going to see in calculus and pre-calc. I don't want to worry about it too much. I just want to show you that it exists. Alrighty. Enjoy. Have fun with these. Find your favorite technique, but always have a backup.